All right, we're starting out with this problem. It's got multiple steps to it. This first part, the idea here is that before we treat this as an equation to solve that you've seen before, you need to combine like terms. We need to combine these terms right here. Why are they like terms? Because this is a constant and this is a constant as well. Okay, so when we combine them, we get 72 plus 4 is 76. Okay, so we rewrite it exactly the same, except these two become what they equal when you add them together. Now, how do we deal with the next part of it? Well, before we can deal with this, multiplier of d, negative 14, we need to get rid of this positive 76 that's being added to it. And I say being added to it because it's positive. Okay, so that becomes something that's undone by subtracting that equal amount. Okay, and so we rewrite the original equation on the left-hand side, but following it with minus 76. That's going to undo this. Okay, and then we say, well, then we have to write this side with the minus 76. So we've done the exact same thing on the left side, minus 76. Exact same thing on the right side, minus 76. Now we're simplifying each side by combining like terms. The like terms over here are the 76 and negative 76. Those are constants. And on this side, 36 and negative 76, they're also constants. So the whole point was to make that 76 go away, which it did with the minus 76, leaving just negative 14d. And over here, we've got 36 minus 76 is negative 40. Remember my rule that I said, if you're subtracting more than there is there's only 36 here, but you're trying to take away more than 36, okay? You can reverse the numbers, do 76 minus 36, which is 40, and make the result negative, okay? And I'm happy to explain why that works in person. It's a little bit more helpful to do it in person, okay? Then, what's happening now to d, it's being multiplied by negative 14. We undo that with the inverse operation of divided by 14, negative 14. And we do that to both sides, okay? So this will then, negative 14 over negative 14 is 1, so that's 1d, or just d. And then this can be simplified. Okay, the negatives cancel out. Negative divided by negative is positive. And the 40 and 14 are both multiples of 2. So you can divide them both by 2, and what you result in is d is equal to 20 over 7. I'm happy for you to keep that as an improper fraction, but you need to simplify it. You need to have those negatives cancel out, and you need to divide top and bottom by 2 in order to bring it down to lowest terms, as they say. Now, what's the proof? Well, the proof, we start by writing the original equation untouched. If you don't do that, you're doing it wrong. Easy first step. Easy second step as well is to take the exact same equation and write it, but wherever there was a variable, in this case d, you put in parentheses and the value that you found as your solution that you boxed in over here. So plug that in. Now we need to simplify. The first thing we need to simplify is we need to do multiplication, because order of operations, now that we just have a numerical expression on the left side, order of operations is what we use to simplify it, okay? And check out what's going on here. This 14 and this 7, they're both multiples of 7. So you can divide top and bottom by 7. 14 divided by 7 is 2. 7 divided by 7 is 1. So you end up getting 2 times 20, or 40, over 1, which is just 40. So now you're subtracting just 40, and that looks like that. Now, order of operations, we are at the addition subtraction stage. We come from the left and we say what comes first, and what comes first is this addition. So we do that first. 72 plus 4 is 76, and we write everything else the same. Minus 40 equals 36, okay? And finally, last thing that we do is we combine this 76 minus 40. 76 minus 40 is 36. 36 equals 36. Check. That is a proper solution and a proper